Okay, so now we're going to look at another rule in probability known as the addition rule. The first thing we need to do is learn a new definition for mutually exclusive events. Two events are mutually exclusive if they cannot occur at the same time. Suppose A is a person is born in New Orleans and B is a person is born in Tampa. One person cannot be born in two different cities, so those events are mutually exclusive. Now suppose this diagram here is known as a Venn diagram, and let's let this entire sample space include the event of going into Dunkin' Donuts. And the event A is you buy coffee, and event B is you buy donuts. Now it is possible to go in there and buy both coffee and donuts. This light purple over here in A is all the people who bought just coffee. This light pink over here is all the people who bought just donuts. But this dark purple in the middle, where they overlap, are people who bought both coffee and donuts. Since one person can buy both coffee and donuts, these events A and B are not mutually exclusive. So let's decide if the events are mutually exclusive. Roll a 3, roll a 4. There is no die roll that can be both a 3 and a 4, thus those events are mutually exclusive. But one student randomly selecting a male student and one student also being a nursing major, well, one student can both be male and a nursing major, thus these are not mutually exclusive. The addition rule is used for finding the probability of A or B. When you say the word or, think addition. The probability that events A or B will occur is the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Let's go back to our Dunkin' Donuts example. And A, remember, was the probability that you bought coffee. B is the probability that you bought donuts. But remember, there were some people who bought coffee and donuts, and we counted those people twice. We counted them when we counted the coffee people, and we counted those people again when we counted the donut buyers. So we have to subtract it out once. But if the events A and B are mutually exclusive, then the probability of A and B is 0, and thus it just becomes the probability of A plus the probability of B. This rule here can be extended to any number of mutually exclusive events. Only mutually exclusive events. Can you just add a whole bunch of them? Suppose we select a card from a standard deck, find the probability that the card is a 4 or an ace. There is no card that is both a 4 or an ace. So when we count the 4s, there are 4 out of 52 4s, and there are 4 out of 52 aces. We counted no cards twice, so the probability is just 4 over 52 plus 4 over 52, which is 8 over 52. Now, if we want to find the probability of rolling a number less than 3 or rolling an odd number, well, there are 3 odd numbers, 1, 3, and 5, and there are 2 numbers less than 3, the 1 and the 2. Notice the 1 falls in both circles, so these events are not mutually exclusive. So the probability of rolling the number less than 3 was 2 out of 6. The probability of rolling an odd number was 3 out of 6, but we counted this one when we counted up this and when we added this in, so we need to subtract it out once, and it's equal to 4, 6. 2 plus 3 minus 1 is 4, 6. Suppose we want to find the probability that a particular sales rep sells between 75,000 and 124,999. Well, these are mutually exclusive events. So the probability that any one person sold between those two amounts is 7 plus 9 divided by 36, because 3 plus 5 plus 6 plus 7 plus 9 plus 2 plus 3 plus 1 is 36. And so 7 over 36 plus 9 over 36 is 16 over 36. Let's look at another example using the addition rule. Suppose we want to pick one donor and find the probability that that one donor has type A or type O blood. Well, the type of blood we have is mutually exclusive. There's 184 out of the 409 that have type O blood. 164 out of the 409 have type A blood. We counted nobody twice. So that probability is 184 plus 164 divided by 409, or approximately a little over 85% chance. Now suppose we look to find the probability that the donor has type B or is Rh negative. Now type B blood, there's 45 out of the 409 who have type B blood. There is 65 out of the 409 that have Rh negative blood. But notice that we counted these 8 people twice. We counted them when we counted the type B blood, and we counted these 8 again when we did the Rh negative. So we're going to need to subtract those 8 people out once. So 45 plus the 65 minus 8 is 102 divided by 409. So that's the end of section 3.3. Now go to the Course Compass website, to My Math Lab, and do the homework set for section 3.3. That's all we're going to be doing in chapter 3. Your next lecture will be starting up with section 4.1.